Good afternoon, everyone. My name is Ryan Price, and I'm very, very happy to be here and part of the Databricks Summit, and looking forward to sharing a great story with you here today. So welcome everyone. We'll just go ahead and get started. And today we're going to talk a little bit about Databricks and some data science work that we're doing here at Avanade in the Netherlands. And I'm joining you today from my home in near Boxmeer in the Netherlands. And yeah, a sunny day outside. And unfortunately, we're not actually live, being able to do this together as we have in the past. We're doing this under the current circumstances with COVID, which is unfortunate, but glad that we can still do it in this format anyway. So thanks again for joining. So my name is Ryan Price, and I lead our data and AI practice here in the Netherlands. I've been doing that for about the last 8 years. I've been part of Avanade, and my role here is I'm responsible as a solution architect for solutioning and supporting our sales teams and leading a team of solution architects to create solutions like the one I'm going to talk about today and deploy these for our clients. And we do this over the full breadth of the data and AI span. So from data platform to intelligent industry solutions to intelligent automation. So really the full span of the data and AI space. I've been doing this, as I said, about 8 years. Before that, I spent 25 years in the defense industry, where I was doing also a lot of data science, and working with data. But also a lot of program management and things of this nature. So always involved with technology. It's a passion of mine. And in my spare time here in the Netherlands, I enjoy spending time in the outdoors. And I was a pilot also in my Air Force career, so I really still enjoy to get out and do some flying. And I really like doing the work that we do at Avanade, and spend a lot of hobbying time in that space as well. Later on today, Alexander Schertsnov will be joining me for the question and answer session. And Alexander is a very highly competent data scientist. He's been working on things like the accelerator, proton accelerator program, doing a lot of university work, and will be a great addition to our session and question and answer today. And he was also involved in solutioning and in the delivery of the project we will be talking about today. So also, I'd like to, for those of you that haven't heard about Avanade, so I'd like to just to talk a little bit about, introduce us. Avanade, we've been around since 2000. We're a joint venture between Microsoft and Accenture. And in the meantime, we've grown over the last 20 years to more than 40,000 people located across more than 20 countries, and you see some of the stats here in the presentation. But we focus on the full breadth of the Microsoft platform. So today, what we're talking about falls under our data and artificial intelligence group, but we also have a modern workplace, business applications, and applications and infrastructure. So we operate over the full spectrum of the Microsoft practice. And here in the Netherlands, where I'm presenting from today, we have a team of over 400 people that are dedicated to the Microsoft platform, and those that are involved in the data and AI piece, about more than 200. So doing everything from deep data science work to data platform work to intelligent automation over the full gambit. So I'm also very proud of our collaboration that we have with Databricks. So we have more people trained on the Databricks platform in Europe than any other company. So we're really, really proud of our work that we do together and our partnership with Azure Databricks. So again, thanks all for joining. So a little bit of background about the client. We're talking about a major client, a supermarket and consumer goods client here in Europe. They've got operations across multiple countries and quite some scale, as you see here. Well over 2 billion in turnover. more than 100 million transactions, 50,000 different articles, and several million people working at the company as well. So we've been working and engaging with this client for a number of years, and both in the Azure Data Platform space, so providing support there, bringing all of the data together, but also in the on the high value side, so delivering data science models and helping provide and demonstrate also the insights. So pretty exciting work. It's as you know, retail consumer goods, very tight margins. Things like pandemics can have a substantial impact, and which really makes the opportunity to create high value with data science quite opportune. So good stuff there. Yeah. So if you look at the typical kinds of things we're doing in data science and consumer goods, and in this supermarket industry, we're looking at things like store sales forecasting. Online marketing is quite interesting. Loyalty programs, customer journey, customer engagement. All of these things are the areas that are getting a lot of focus and can create quite some value. And we've really and then what we're talking about today will be specifically more focused on the online marketing piece. So just to talk a little bit also about the industry. So I know that we probably have a lot of industry experts in the audience today, or that are tuning in. But for those that maybe don't have quite so much, just a little bit of background. So specifically what we're going to talk about is an online cross-sell model that we used relative to this online marketing we just talked about. So, what is it? Yeah, the idea is that we want to, try to cross-sell a particular product, or which results in selling more than what you might have. So, for example, if I go into a supermarket and if I look at the shelves, you'll see that they're arranged also to achieve cross-sell. So maybe I go in and I choose a Coca-Cola, and you might find that you have peanuts very close to the Coca-Cola or the soft drinks, because the chance of you buying peanuts if you buy a Coke, if they're situated next to each other, might be higher. And so this is the same kind of thing, but then on sell. Online. So, but what this isn't is replenishment, stock replenishment, or predicting replenishment, or things of that nature. This is really about creating additional value. And why do you want to do this? Why is this interesting? Yeah, because bottom line is it can increase revenue, really enhance the customer journey. We know how important that is. If you've ever been online and you get recommended a product that is totally nothing you would ever buy. As I mentioned, I like flying, and I also like doing outdoor things, whether it's sports or fishing. And if I get recommended a product that's interesting to me, then I might actually click on and take a look at it. If I get offered something that's not interesting, not only will I probably not click further, I might even get irritated and not want to shop there anymore. So these are the things that are quite important in this kind of marketing. And ultimately, what we really want to do is encourage our customers to get a little bit deeper in their pockets and spend a little bit more. So they'll be happier, have a better experience, and ultimately will be happier because we are selling more. And how do we do that? Again, just to repeat a little bit, but it's all about providing relevant recommendations, and how do we further do that? Behind the scenes, we're using data science and statistical modeling to help predict or help make the proper recommendations. So that's the kind of the details behind the scenes that are going on. So important also to note that the model isn't personalized. That is to say that it wouldn't offer me something any different than another person. There isn't a personal element to it. It's purely based on the product itself. So if you buy a particular product, then what's the likelihood that any person would buy the next product that's recommended? And and if you look at what are the metrics that are measured in the industry in this space, so you're looking at what is the additional turnover, and looking at conversion, average number, from a per basket perspective. And we had in this particular example, so we're several months into it now, and really so far we're showing about an additional 3.5% turnover. So what is that? 18 million a year if we project this out. So and things continue similarly. So quite a positive impact. And also, if you look at it from a conversion perspective, 2 additional products per basket, which is and if you go out over a year, then you're looking at 10 million products. So this is this is having a significant impact in a time where there's quite some challenges in the market. So very positive. So now let's take a look at the modeling approach. So basically, what we want to do is be able to predict a list of relevant cross-sell products based on, or what we call child products, based on the parent product that a customer puts into the basket. So if you look at the scenario that's shown here, and the way the algorithm is working is it's basically going to analyze all possible product pairs that could be brought together, and it will define the pairs that are more likely to be bought together and then independently. So and we're doing this with binomial statistics test, and it basically at the end it will select the pairs with the novel child products, and this is also done with binomial statistics testing again. So that's a little bit of data science, but if we look at it in terms of maybe a bit more simplistic, if we look at the depiction here, if you have a basket that has products in it, in this case we're talking about Greek yogurt and croissants, and if what we're saying is if you had placed Greek yogurt in your basket, then and you're offered a croissant, the chances are quite high. The probability is quite high that you would elect to purchase that. And as you can see in this particular case here, whereas it would result in 200,000 sales, then it would result in a further 100,000, so 300,000 products that would be sold. So basic conclusion is, if you somebody that would like to buy Greek yogurt will probably also want to buy a croissant. So, but who wouldn't want to buy a croissant? They're good, right? Especially when you're on vacation in France for the summer. Okay, now I'm just going to talk a little bit about the data sources and architecture. So this isn't really a depiction of the full data platform. It's very much zoomed in on the specific data science work that we're addressing and talking about here. But it was basically deployed on a very large scale Azure data platform, and we're using Databricks as our data science and big data motor to do this work. Although the model itself is run in batch, it is actually being consumed the data is being consumed, results are being consumed in real time. So just to walk across, and if you look at the orchestration of over the entire breadth from ingestion to consumption is being orchestrated with Azure Data Factory. Again, we're using Azure Databricks as our big data and data science platform. If you look at the required data in this case, so our data sources, we're harvesting basically raw transaction lines, the product master, product hierarchy, and in some instances there might be data that's blacklisted or seasonal products, and so for the stores where that plays, we can also take that into consideration. We then are taking the data, ingesting that into Databricks, where we're doing basically some data preparation, so some data wrangling, and eliminating any poor quality data or addressing any things that might come up to make sure that we have good data quality and good data preparation. And then we're moving along into moving our data into the data lake, where after we've transformed it and created the product data that we need, and then we can actually ingest it from there into our data model and run the data model that's basically making the cross-sell product pairs and the prioritization, and that's being consumed by Azure Cosmos DB. And that from there we are able to use the online website to actually consume the recommendations and the results of the data model. So, and that's done again So we're running the model in a batch scenario, but we're consuming in real time. So just to give a little bit of detail about the architecture that we're using here. So now just talking a little bit about the modeling results. So again, I think we're pretty excited about the value that we were able to create with this project. So some of the results, it is a complex model in the sense that there are over 15 different parameters, and it requires a grid search for the optimization. And if you look at that, the two main metrics for this is our parent coverage. So what we mean by that is how many products will have cross-sell products associated with them, but also child coverage. So how many products become cross-sell products, and that's percentage of the assortment. And on the right, you see there some of the parameters in the table. And basically how do we do? So if you look at the parent coverage, it was if we're looking at the model returns at least for at least 6 cross-sell products, we had more than 90% coverage of the assortment. So I think that's quite impressive. If you look at the child coverage, so 92% in this case. So that means that the 92% of the assortment appears as a cross-sell product for at least one product selected by the customer. And so I think both over 90%, which is quite impressive. And the model, if you look at the model, is taking about 50 minutes to run. We're using a cluster of 13 from 4 CPU virtual machines, and using on Azure Databricks. So it's, even though it's quite a heavy setup here, we've got still taking a little bit of time to run because of how much data we're actually dealing with here. It's fully automated, and right now we're running it every 2 weeks. And again, we're scheduling this, orchestrating this with Azure Data Factory, but that is adjustable. We can run it more frequently or less frequently if we find that that's more optimal. If we look at this, just shows some of the example outputs. So for these wafers on the left, you can kind of see a number of the recommended pairings, and those are actually ranked so that you start from highest and move down. So this just kind of gives you a tabular form to see what really all of this data science is resulting in that's running in the background. So why Databricks? What is the real value that the Databricks, and why is it uniquely positioned to provide to be a great platform to do this on? So one of the main things is calculation tractability. So this model needs to be run on a distributed cluster in order to be able to provide the performance we need. And we know Databricks is very easy to do that. It's very easy to scale out and increase your performance. This is big data. So we've got over a year of historical data, including 900 million transaction lines, 40 gigabytes just for that, and it's estimating child product novelty and 1 month of data to run the market basket. So this and doing all the calculations for the binomial probability. So this is definitely a big data scenario. And also your memory consumption is unpredictable here. So internally, the model is really building on the possible product to product pairs, and there are dozens of millions of transactions. So it's really impossible to estimate your memory consumption there. So Spark is very advantageous, and of course we all know Databricks leverages Spark. So and when you're looking at these kinds of scenarios, it's very helpful. And if we also look at productionizing requirements, the productionizing patterns, so Databricks really allows you to run various models in batch. So we're running 4 different models and then productionizing them with the same pattern. So also something that Databricks is well suited to do. Data availability. So all this data is in CSV, Parquet files, or Delta tables, and stored in data lake. It's mounted easily into Databricks notebooks. So also the the interaction, integration with Azure and Databricks is also quite handy here. And lastly, the integration into the business pipelines. So Databricks notebooks, as you know, are may or may not, but it is very easy to schedule with Azure Data Factory for consumption. So it's just a great platform for Databricks, whether it's you're doing data engineering work, as we mentioned earlier, or you're doing the data science, or you're doing the business analysts. It's just a great collaboration platform and way of integrating those various activities into a process. So lastly, just to wrap things up, I think what you've seen here today is not a highly complex case. I think we see it quite often, but I think it really does illustrate the power of Databricks and the power of big data computing and how it can bring value to your clients or to the market, and especially in times like now with pandemics. This is a capability that can really be interesting to help improve the bottom line. And again, even though it's based on a fairly simple idea, it also really shows significant high level of success. And though the statistics have been around for years, we've been able to do these things mathematically, but we haven't had the big compute engines that were able to do these from the compute side and the technical side. And now we really are, Databricks is really a game changer in this space. And a lot of large retailers, consumer goods, products companies, they have these massive amounts of big data. Conversion and turnover is absolutely important. And whether it's replenishment, forecasting, we've only touched lightly on a scenario today. There's of course many more scenarios, big data scenarios that could equally bring value. But today was just to zoom in on this one particular interesting case. Lastly, Databricks really, again, I've mentioned it already a couple of times, but it's really helping us in terms of bringing the full breadth of the business together with IT, joining these two worlds from the data preparation and data wrangling that data engineering and analysts might doing to actually building the data science models that our data scientists would be doing, providing the engine underneath that for the compute that's necessary to handle these big data kind of scenarios, and then ultimately on the consumption side, having making easy access for our business analysts, and in this case, having it being consumed in something like an online website is quite easy to do. And really, I think an equally important aspect is the ability to industrialize this and really create a productionizable solution that can bring value. So this is the presentation for today. I would just like to thank everybody for your attention. I hope you found it informative, interesting, also relevant in the times that we have. And of course, we're here to also talk about Databricks, and as a very important partner to Databricks, we're also quite happy to be able to share this kind of story and our passion for working with the technology here at Avanade. So now what I would like to do is hand this back to you as those participating. And again, thank you for dialing in. And what we'll do now is open up to a number of questions. And Sasha will join me as well. So if you have some of the real technical data science questions, he will be able to help out on that front as well. So again, thank you very much. And we look forward to your questions. And I hope you have a great summit. Take care. Thank you.